This is a review for the first unit. Name the common endpoint of SR and ST. SR and ST are opposite rays. They have this common endpoint S. 4 coplanar points would be in plane S. We have points A, F, G, and E. A line containing both points B and C, we can call this line CG, or GB, or a variety of other names as long as it involves two of these 3 points and the arrow above them. A plane that contains A, G, and E, we can call this plane S, based on this cursive letter without a point here. We could also name it by 3 points in the plane that are not on the same line. So we could call this plane AFE if we wanted to. Here's an example of 3 coplanar lines intersecting at one point P. If I wanted to draw a line containing P and Q, here's my line, here is P, and here is Q. For number 8, a pair of opposite rays, both containing C. Well, C will be my common endpoint, and we'll head that in this direction, CB, and in the opposite direction, CA. That's for number 8. Number 9, line CD intersects plane P at B. So here's plane P with a point B on it, and line CD passing through it. If we want to find the length of XY, we can take the absolute value of the difference, or we can just count over 1, 2, 3. If S is between R and T, by the segment addition postulate, we can add these two together to equal the whole. So we can set up this algebraic expression, and we solve for X. Once we do that, we need to plug it back in to find RT. Turns out that answer is 8. To find the length JL, we are counting over 1, 2, 3.5, so that length is 3.5. To find HK, we are counting over 4, 5, so that is 5. If Y is between X and Z, here's X, Z, and Y, and they give us these distances, 13.8, and they tell us that the entire distance is 21.4. To find the missing one, I just subtract the difference. This gives me 10.6 for YZ. For 13, I can set up that PQ plus QR is equal to PR, and algebraically it looks like this down here. When I solve for X, I get 2. If they want me to find PR, I plug that in right here. 14 times 2 is 28, minus 6 is 22. For 14, if U is the midpoint, then these two things are equal to each other. So 3x plus 4 is equal to 5x minus 2. If I move all the x's to the right, I end up with 2x. And if I move all the numbers to the left, I get 6. Since x is equal to 3, they want me to find each of these parts. So 3 times 3 plus 4, this one is 13. 5 times 3 minus 2 is also 13. So the two put together is equal to 26. For 15, we have a similar situation. We can say that 9x is equal to 4x plus 10. So 5x is equal to 10. X is equal to 2. If we plug that in, we have 18, and the whole thing together is 36. Classifying several angles here, ABC is acute because it is less than 90 degrees. CBD is also acute. ABD, these two angles put together, is bigger than 90 and less than 180. That's why it's obtuse. DBE is less than 90, and CBE, which is these two angles put together, is obtuse. Since KM bisects angle JKL, these two angle measures are going to be equal to each other. That's the definition of an angle bisector. I can solve for X and get 3. They want me to find the measure of JKL, so I plug 3 back in, and I get an answer of 26 degrees. For 16, I have a right angle, an acute angle, another acute angle, and if I wanted to start combining these, I could say things like VYW is equal to straight, but that's enough for there. For 17, this is an angle addition postulate question. We can add these two angles together, and they're equal to the total angle, 116 degrees. So we can combine like terms. Subtract 47 from both sides. When you divide, X turns out to be 3. They want to know what the measure of MNQ is, which is this entire angle. They want to know what the measure of HJK is, which is this right here. So we plug in a 3. 13 times 3 is 39, plus 20 is 59 degrees. So here's my angle MNQ, and NP bisects that, or cuts it into two equal parts. So the first angle here they give is 6x minus 12 degrees. And the second angle they give, PNQ, is over here, 4x plus 8. If I want to find the entire thing, I can set these two equal to each other, solve, and then find one of them and double it. So here's my initial equation. This gives me 2x is equal to 20, or x is equal to 10. So I can plug that in over here, and 4 times 10 is 40, plus 8 is 48. If I double that, I get 96 degrees, because this one is also 48, since they're equal to each other. So in this diagram, 1 and 2 are adjacent, meaning they're next to each other. 2 and 4 are not adjacent, because they don't share a common side. 2 and 3 are adjacent, and they form a linear pair, meaning they add up to 180 degrees. And 1 and 4 are adjacent and form a linear pair also. To find the measure of the complement and supplement of these angles, we just take 90 minus or 180 minus. When we have actual numbers, we can get a direct answer. However, when we have a variable, we just subtract that expression. Remember to distribute the negative, and this turns out to be 98 minus 3x and 188 minus 3x. So 1 and 2 are adjacent, but they are not a linear pair. 3 and 4 are both adjacent and a linear pair. 2 and 5 are not either one. For 22, the complement, I take 90 minus. For the supplement, I take 180 minus, and these are the values I get. The same thing for 22, I take 90 minus this expression, so I end up adding 4 since I'm subtracting a negative 4. And the same thing with the supplement, I take 180 minus this expression, and in both cases I have the 94 and the 184 minus 2x. For 24, when they say an angle measures 5 degrees more than 4 times its complement, we'll call the complement x. So the angle is 4 times x plus 5. And these two together equal 90. If I combine like terms, subtract 5, and divide by 5, I get 17. So then I can take 4 times 17 and add 5 to that. This gives me 73 degrees. To find the perimeter and area of this triangle, we use the formulas. The perimeter, we just add together the outside edges. When we combine like terms, we get 5x plus 15. For the area, I have to find the base, it's this one, and the height, multiply them together, and divide by 2. So remember that 3x times 2x is actually going to be 6x squared, and then once I cut it in half, I get 3x squared. And 5 times 2x, 10x, divided by 2 is 5x. The formula for the circumference and area of a circle, 2 pi r, I plug in 11. If I was to round to the nearest tenth, I get 69.1. For the area, I take 11 squared times pi, 380.1 centimeters squared. For 25, the opposite lengths are equal. If I add up all the x's, I get 14x minus 2. That tells me the perimeter. To find the area, I'm going to multiply 3x times 4x minus 1. So this is 12x squared minus 3x. And that's the area for number 25. For 26, I take a side length times 4 to find the perimeter. So this is going to give me 4x plus 16. That's the perimeter. To find the area, I multiply x plus 4 times itself. And I like to use the box method for this, but whatever method you choose, you get this value for the area. For 27, for the perimeter, I just add together the outside edges. 12 plus 8 minus 5 is 15, plus the x, that's the perimeter. To find the area, I'm going to take 8 times x minus 5 divided by 2. So this gives me 8x minus 40, or 4x minus 20 for the area. For 28, to find the perimeter, it's going to be twice the length plus twice the width. So this is going to be 54 plus 10x for the perimeter. To find the area, I'm going to multiply the length times the width. And this gives me 100x plus 140. And that's the area. 29, the radius is equal to 21. If I want to find the circumference, that's 2 pi r. So that's going to be 42 times pi. If I rounded that to the nearest tenth, I get 131.946, and I basically round it to this, 131.9. That's the circumference. To find the area, I'm going to take pi times 21 squared. So that gives me 441 pi and 1,385.4 meters squared. And this was meters. That equals to the area. In 30, they give me the diameter is 14, so the radius is going to be 7. So this is going to be 14 pi for the circumference, and this is going to be 49 pi for the area. If I multiply those by pi and round to the nearest tenth, I get 44 and 153.9. For 31, I have to work backwards. So base times height divided by 2 is equal to 102. And they tell me the base is 17, so I can plug that in. And let's multiply both sides by 2 to cancel this out. I have 17h is equal to 204. If I divide both sides by 17, I get that the height is 12 meters. In this example, x is the midpoint, so we have the coordinates of the midpoint and one of the edges, endpoints. To find the other endpoint, we can just recognize the pattern. To get from C to x, what did we have to add? Negative 4 to 7. We had to add 7. To get from 1 to negative 2, what did we have to subtract? We had to subtract 3. So if we do that again, from x, we end up with 10, negative 5. I like this method better, but here's how you can formally use the actual formula to figure it out. In this next example, we use the distance formula or the Pythagorean theorem to find the distance between 2 points. For the distance formula, we take the difference in the x-coordinates plus the difference in the y-coordinates, and they're squared and underneath this radical, and we get 5. We can also draw out a triangle. So if we plotted these 2 points and drew the side lengths, we would get 3 and 4. So if you square those and add them together and take the square root, you get 5 as well. For this next section, they tell me that y is the midpoint. So if I have the 2 endpoints, I'm just going to take their average. So 3 plus the negative 1 is 2, divided by 2 is 1. 2 plus 4 is 6, divided by 2 is 3. In this next one, I have one of the endpoints and the midpoint. So how did I get from 5 to negative 2? I subtracted 7. How did I get from 0 to 3? I added 3. So let's do that again. Now we're at negative 9, 6. Similar thing here. How did I get from negative 4 to negative 2? I added 2. And how did I get from 4 to 3? I subtracted 1. If we follow that pattern, I'm going to end up with 0 and 2. For 35, if I wanted to draw the triangle, I can think about the distance between these 2 x-coordinates, and it's 8. The distance between these 2 y-coordinates, and it's 3. So I draw the triangle using this for the base and the height. The hypotenuse is the square root of 8 squared plus 3 squared. So that's the square root of 73, which gives me 8.5 if I round to the nearest tenth. For 36, I'll do the same thing. To find the difference in x-coordinates, it's 2. The difference in y-coordinates is 7, drawing not to scale. The square root of those 2 squared and added together, this is 49 plus 4. So the square root of 53, or 7.3. The last one, we'll use the actual distance formula here. So this is x2 minus x1 squared plus y2 minus y1 squared. So if I simplify a little bit, this becomes the square root of 49 plus 16, or the square root of 65, which if I round gives me 8.1. And then in 6.1, we can tell whether a figure is a polygon because it's a closed plane figure made of segments that intersect only at their endpoints. In this case, it has 6 sides, so it's a hexagon. This one is equilateral, but it is not equiangular, meaning the side lengths are the same, but the angles are not, so it's not regular. And no diagonal contains points in the exterior, so it is convex. To find measures of the sum of interior angles, I take the number of sides minus 2, multiply by 180, and I get 1620. To find the measure of each individual exterior angle, I recognize that the sum of exterior angles is always going to be 360, and I divide by the number of sides. Here, it's a pentagon, so I divide by 5, and I get 72. So number 5 is not a polygon, because it's not a closed figure. Number 6 is a polygon, and this is a triangle. And number 7 is a polygon. It's a concave polygon. I can call this a 12gon because it has 12 sides. Or more formally, I could call this a dodecagon, but we don't need to memorize that. So are these regular or irregular? Are they concave or convex? So this one is the only one that is concave because the diagonal is in the exterior. So this one is concave. And the others are all convex. All of the side lengths and angles are the same, so this one is regular. This one we have different angles, or I'm sorry, different side lengths. So this one is irregular. And here we have all the same side lengths and all the same angles, so it's back to being regular. And if we actually look back, remember that regular polygons also have to be convex, so that is why this one is not a regular polygon. For number 11, dodecagon means 12 sides. So I can take 12 minus 2 times 180, and this gives me 1800 for the sum of the interior angles. For number 12, to figure out the total sum, I take 18, that's 20 minus 2, times 180, and this gives me 3240. I divide that by the number of angles, 20, and it turns out each one is 162 degrees. For number 13, exterior angles always add up to 360. If it's a quadrilateral, there are 4. So 360 divided by 4, that answer is 90 degrees. For a hexagon, well here, this specific hexagon, I can add up all these different angles, and they have to equal 720 because I take 6 minus 2 times 180. So 40s is 720, or s is equal to 18. If I wanted to plug that into each spot, these are 90-degree angles here. These are 126. And these are 144.